So for you to really understand what complex analysis is about, you have to understand very well what complex number talks about. Because basically what we are analyzing in complex analysis is complex numbers. Now I'm sure we all remember the concept of natural numbers, real numbers, quotients, integers, and the likes. Real numbers. Now, the mother of all this is our complex number. Now, what differentiates complex numbers from every other number, from even real number, is I. This I, and the mathematical value for I, is root of minus 1. That is basically what makes complex number complex. This I is the complex variable in complex numbers. So you already know that the first, like the I, mathematical value of I is root of minus 1. And how I came into place is because we needed to look for the root of negative numbers. For example, root of minus 4 now. According to Saul, the same thing as root minus 1 times 4, which is root minus 1 times root 4, which will be root 4 is plus or minus 2. And since I already said our root of minus I is 1, is root of minus 1 is I, so our answer will be plus or minus root 2I. Okay, so that is plus or minus 2I. So I basically is what makes a complex number. So this is a complex number, and all complex numbers are written in the form z equals to x plus iy. This is the Cartesian form. As we proceed, we are going to see other forms, but for now we'll be dealing with Cartesian form, and we'll be talking about algebra of complex number, which is the adding, subtraction, the multiplication and division of complex numbers. Now, addition and subtraction of complex numbers are very, very simple and basic. If I say z1 equals to, let's say, 2 plus I, z2 equals to, let's say, 4 minus 2I, and z3 equals to, let's say, 5I plus 6. Yeah. And I say find z1 plus z2 minus z3. For example, so we are combining addition and subtraction together because it's very easy. So what's our z1? 2 plus I, plus what's our z2? 4 minus 2I, minus. Now if you notice, when we're adding it, we didn't, the plus didn't affect any sign, but because it's minus, it will have to affect everything here. So that will be 2 plus I minus 4 minus 2I minus 5I minus 6. Now the way of how to add and subtract is combine the real part, the complex imaginary part, and the real part. So this will be I minus 2I minus 5I plus 2 minus 4 minus 6. So this should be minus 6I, and this should be minus 8. Okay, so basically, and there's one thing you need to know: real part is the part without I. So our real part here is 8, and our imaginary part is the part with I, and our imaginary part is minus 6. Note, I is no more in minus 6. So here the real is minus 8 and the imaginary is what? Minus 6. So example, I might ask you to say find the real of z1 plus z2. So what you need to do is you first look for your z1 plus z2, and once you get your z1 plus z2, you have z1 is 2 plus I, z2 is plus 4 minus 2I. So 2I cancels out. 2 plus 4, that's 6 minus I. So the real of this part is 6 because that's the part without I. So real z1 plus z2 equals 6. So adding and subtracting is very, very basic, very, very just add the real to the real, the imaginary to the imaginary, and when you are subtracting, the minus affects all the signs. Now let's do multiplication. Using this same function, z1 equals to 2 plus I, z2 equals to 4 minus 2i, z3 equals to 5i plus 6. Now we want to multiply. If you have multiplication, basically is expansion. So let's say number one, real of z1 z2 plus imaginary of z2 z3, yeah, something like this. So first of all, you need to get your z1 z2. Z1 is 2 plus I, z2 is 4 minus 2i. So expanding it will be 2 times 4 minus 2i plus I into 4 minus 2i. So that will be 8 minus 4i plus 4i minus 2i squared. So that will be, this we cancel out, 8 minus 2i squared. Now I want you to know one thing. Anytime you are solving complex numbers, your highest power of I must always be 1. So here that we have I squared, remember that I is what? Root of minus 1. So if you square both sides, the square will cancel this, so our I square will be what? Minus 1. So that will be 8 minus 2 minus 1. That will be 8 plus 2, that's 10. So 10 can be written as 10 plus 0i. The question says find real of z1 z2. The real of z1 z2 is 10 because it doesn't have an imaginary part. So let's do z2 z3. 4 minus 2i, 5i plus 6. Same way, 20i plus 24. If you don't understand what I like, if you don't understand the skipping the step, you can take it the same way we took this. But me, I'm just going to skip the step because I want to make the video compact. So this will be 20i plus 24 minus 10i squared minus 12i. So that will be 20 minus 12, that's 8i minus 24 minus 10 into minus 1. That will be 8i minus 24 plus 10. That will be 8i minus 12. So our imaginary of z2 z3 is what? 8. So adding, so real of z1 z2 plus imaginary of z2 z3 is equals to 10 plus 8, that is equals to 18.